Thanks everyone for your patience. We apologize for the technical difficulties this morning on the floor, but we will still start. So our speaker for this session is Avi. So he traveled all the way from Israel, and then he works as a data scientist there. And so it's all yours. Take the floor.
So many technical problems now. Really hope that you will see or hear something. So the slides are on the talk in the PyData website. So and it's on the GitHub. So if you want, you can click on it, and so you can see the code. I can describe you if you want. So on the right you see a big mountain, and I'm at the mountain. Okay. It won't be so accessible. Anyways, as she introduced me, I'm a data scientist in CityLab, in the university. I'm also the thesis on explainable AI, master thesis. And it's my first time on the PyData. So I'm really excited, and of the United States, the first time. So it's very excited. And if you don't understand me or anything else, please just tell me. That may happen. So the focus on the talk is on our large language models can improve explainable AI. So there are many directions, so we'll talk about them later. But first, why do we need explainable AI? Okay, there are many reasons. So for example, if you are model developers, if you are data scientists, if you are anything else, so you may need to explain your model to stakeholders. Or even if you are working on a regulated industry, you may need to generate model risk management documents. And whoever working with that know that it's a big burden, because you need to fill many questions about your model. And it takes a lot of time. And regarding the stakeholders, also if you ever generated a dashboard for stakeholders, especially if non-technical stakeholder, you probably know what is the challenge here. When you want to explain a complicated model to stakeholders, they may not have a lot of time to understand it, may not have a lot of patience. And the models can be very complicated. So we have a few challenges in explainable AI. You want to explain to different stakeholders with a different understanding of the what is of machine learning, of even of the domain itself. And also, we may want to do some summarization of the model, some easy summarization of how the model is working. we also something that specifically related to data scientists. Not all the time know the domain itself. We are not the expert of the domain. So we may want some help. We want to ask the LLM, does this actually an anomaly? Does this make sense? So from my experience, for example, I worked on anomaly detection models in finance. It was hard to tell if it was a really anomaly, or what feature makes something an anomaly when you don't have, let's say, label data. Also, with the current explainable AI, you can't really ask follow-up questions. If we, let's say, want to do some deep dive, it's problematic. So in this talk, so we know that we have there are a few challenges in explainable AI, and in this talk we will show simple method how we can combine LLM with explainable AI. And I did this really simple method that everyone can try by themselves. So all the examples in this talk will be on the bike sharing dataset. So this is this dataset we have about 700 samples. It's the count of rental for each day between 2011 to 2012. It's for rental in Washington. And also the code itself is in the website. It's on the GitHub. So you can click on the presentation and see the code. In the end of last year, Microsoft published a paper that they called it Talk to EBM. So EBM is a method to create models that are we call them glass models, meaning or interpretable models. They are models that you can understand how they are working, just by looking at the values and the training. For example, if I want to understand how this model predicted, let's say, price of a house, I can just look exactly at the functions that this model is using, and then I can compute it myself. So this is very special kind of a model. Actually, its name is a Generalized Additive Model. This is the specific model. And what they show is that if they can use LLM to do some summarization of datasets. And also they can summarize this specific model. So the LLM itself can add some prior knowledge. For example, domain knowledge on the specific subject. And you can use this knowledge and the knowledge of the EBM model to find some anomalies or some surprising effects, or maybe some problems in the data. But this was only a specific EBM model. It's not for every model. So here we see in the next slide, we see more details about this model. So overall, this model is additive model where we train a specific function on one feature. On each feature have a function that train only on itself. And so we have later we can convert those functions to text and send this text to the LLM. So each time we send one function to the LLM, and LLM can go over this function and it can analyze it and see if it's making sense, if there are any problems with it. So overall, there are a few problems here. One problem is that the function can be big, so it can take a lot of tokens. And also, of course, it's on this very specific model. So some background before we will show the method. Like Sharp, of course, is very, very popular. I guess 99% of you already experienced with it. But for those that didn't, the idea of Sharp is that you can take any model, you can see any black box model, and find out what is the contribution of each feature to the prediction. So, for example, in these slides, we have a model predict specific values, like 0.4, and we know exactly how much each feature added to this model. We see that the age had the biggest contribution, and after that, the sex had a very big contribution. So the focus here is that so we can generate the values, or even can generate some sort of function for every model. And so our method will use Sharp, and we generate functions very similar to what the Dr. IBM did, but with the scatter plot. Meaning we generate scatter plot. What those scatter plots are? We take all the samples in the data sets, or even a few of them, and for each of them, we generated the Sharpie values. That means we know what is the contribution for each feature, for each sample, and then we generate this plot. So in the plot, for example, we have three plots we see. This is some simple example, and each of them you have many dots. Each of the dot is a sample for the data set. That means we have a data. Data can be big, and we have some model trained on this data. It can be any model. It can be XGBoost, random forest, even a neural network. And then we use the Sharp to generate those scatter plots, which help us to understand what is the contribution of each feature for each sample, and later we send those plots to the LLM. And this is some example of a plot that we generated. So this is what is the contribution of the month to the number of rentals of bikes. So on the x-axis, we see the number of months, meaning we have February, April, June, August, October. And on the y-axis, we see the contribution. So for example, we see when on August, and between April to August, we see an increase and positive trend. That means this is more or less the summer time. So in the summer, we have more rentals. So when the month, when we are in the summer, we have see this trend, and later we have seen some decrease. Probably because we go to the winter. Okay, so what we are doing here, are we actually, what we send to the LLM, we send some context. First, we want the LLM to know what this plot is about. So the context is, meaning this is, we have the context of the data set, meaning what is this data set. This is a bike rental of Washington. What is the model about? The model predicted the daily rental of the bikes, and we added the plot itself. And more or less that's it. So we give all this information, and you can send it to the LLM. Now what the LLM gave us is the summarization. So we have an overall summarization of the graph that we send to the LLM, and it also send us some maybe some surprise that he found. For example, that maybe you think that a lot of rental on December compared to January, which is surprising. And additionally, the LLM itself can spot specific regions in the graph, or even specific samples. And later we can highlight those samples, and it's a show it to the stakeholders. So how it's done, as we showed, we generate some prompt with the information about the task, about the data set, and also we have some prompt of the system with what we want to that the LLM will do. So overall, this is a complicated task, and you want, of course, to increase the accuracy of the LLM and make it easy for him, and also we want to make it easy for us to validate that the LLM actually understood this graph. So we use a chain of fact reasoning, and the main idea is that we, instead of sending one big task, a very complicated task, we split it to few easier tasks. So, and what you see here, for example, is what are the tasks, what are the steps, and what is the example of the output of the LLM in each step. So for the first step, we just want to get some description of the graph, the pattern of the graph. We just wanted to tell us, we see a positive trend, we see some negative. And then, of course, we know that it understands the graph. Next, we want the LLM to find out surprises. Meaning, for example, if maybe an error that should be with negative Shapley value, but actually it is positive Shapley values. So this can be a big lot of output. And in the last part, you want summarization. You want to summarize everything you understood in a very concise way, not many sentences. Because usually for the OpenAI, my experience with OpenAI models, they like to talk a lot. And you usually don't want to read this many text. And so what we actually give to the stakeholder or in the dashboard is the final step. This is actually the answer. But each time we send it to the LLM, we get all of them. And of course, the way we do it, I won't talk a lot about it, but we use a structured output. That means instead of sending each time everything to the LLM and getting the first step and then sending it to the next step and then the next after it, we receive some, let's say, some JSON that tell us all the output on each stage. So this, of course, reduces the cost and the latency. So of course, we have many risks in this method, and one of the risks, and of course it's very common, is hallucinations. And, overall, I didn't see a lot of hallucinations with this. Let's say, at least with simpler data sets. But what we can do to make it the LLM better and more accurate is, of course, to improve the description. Meaning, you want to give a good description for the data set, good context. You want to give a good description for each feature. This is very important. Of course, after we give the description, the LLM will know much better about each feature. Because it can give can make mistakes, can make a better, if you want to make sure you can understand the features in the dataset. Of course, you also can use a bigger model, for example, 4O instead of 4 mini, and you can use other methods like RAG. For example, you can just add when the model wants to find information about a specific feature, you can search using the RAG. And regarding privacy, each time we send the graph of all the information of the dataset. And so if the dataset is private, it can be problematic. So instead of sending the graph itself, you can of course ask for rules. That means, can you give me, maybe you can ask the LLM to give you what do you think this plot should be, or what is the rule it should follow. And then we can use the, let's say, code to check it. And we can train specific models with a privacy guarantee. For example, we can for EBM, there is a specific version that they have a privacy guarantee. And regarding the cost, we can, of course, change the quality of the images. For example, instead of high, you can set low quality. This usually still will work good, depending on the size of the data set. And of course, we can use a smaller model. And for the big models, for big data sets, and you have thousands of data sets, only the computation of Shapley values can take a lot of time. So we can also we can use almost any other method. You can generate visualization using other dependency plot, which is very fast, or other methods. So overall, we showed a simple method to generate an explanation using LLM. And this is a method that everyone can use. And of course, it's very important still to check if it makes sense, the output of the LLM, because they can get wrong. We didn't show evaluation. So evaluation is important. It's not easy to do it on explainable AI. But we can do evaluation. For example, there are a few methods to do evaluation. One of them to use LLM as a judge. So, just for example, if you want to check if you can use a different LLM to check the quality of the RLM. You can, let's say, ask the judge LLM to validate if the data makes sense, data of the LLM itself. So in the future, we can add a dashboard. So for example, in the dashboard, we can highlight all the anomalies that the LLM found. And you can, of course, add much more evaluation that are important. So overall, this was the main presentation. But also in the appendix, each one, of course, you can go to the appendix and go to the read more. You have all the papers that this method is based on in the read more section. Also on the code on the GitHub. And another part that we can also use LLM that is also in the GitHub, in this method GitHub, is to improve the metadata. And this is also very easy to do. So just for example, we have description. This is, if you look the improved metadata table, you see description of the bike rental. This is the original description. And you also see the original names. And in the new name, you see the improved name by the LLM. So thus, by sending one quote to the LLM, you can improve all the names and all the descriptions. So this is important not only for the stakeholder, but also for the later for the LLM when you work with it, because it will be easier for the LLM to understand if this is what is the what this feature is about. So, do you have any questions?
Okay, yeah, so thanks Abby and everyone being able to accommodate for the technical difficulties today. So we have 5 minutes to open up for questions, if any for Abby. I'll get the mic to you once you raise your hand.
I will just speak loudly as you did as well. The gray histograms on the pictures, I couldn't understand what they demonstrated. I was a little bit unsure as to why there were so many SHAP value data points as well. Could you comment on what did the gray histogram values indicate?
Yes.
And why are there so many blue SHAP values?
Yes, so this is a scatter plot. In the plot we see, so we explain the feature.
Is this slides 10 that you're referring to?
Any of them, where there were many scatter plots.
Yes,
blue scatter plot data points with then gray histogram.
Yes, so the main idea is that we want to show this is all your data sets in one plot. And each dot here is 1 point in your data. For example, all the rental bags that we have from all the days, so we have 700 points. And on the bottom, yes, this is the histogram. So what we see, of course, that this is more or less the same height. So that only means that for each month we have more or less the same days. So the same number of samples. So not a lot of information here.
Any other questions? Okay, one time, second time. Okay, third time. Okay, let's give another round of applause